Now you see h is the variable, therefore the sin x is constant in this case. Now this is of the form sin a cos b minus cos a sin b, therefore numerator will be sin x minus h, sin x plus h into sin x. Here x cancelled, therefore minus sin h by sin of x plus h into sin x. Now you can find out easily the derivative of a to the power x using the definition. Here I have written directly the result, the dx of a to the power x equal to the power x into log of a to the base e. Actually, to find the derivative of a to the power x, we can use the derivative of e to the power x like this. Next, three trigonometric functions I have taken, though I shall work out two out of these three, and students or learners have to work out themselves, yourselves, the other. First of all, cosec x. fx, let fx equal to cosec x, therefore f of x plus h cosec x plus h, therefore f of x plus h minus fx is equal to, cosec means 1 by sine, therefore I write one by sine x. Why we have taken this way? Because we have to use the standard limit x tends to 0, sine x by x, that is equal to 1. Now we simplify. Now, if I take minus sign outside, sine of x plus h minus sine x, that means 2 cosine x plus h plus x by 2, sine c minus sine the form 2 cosine c plus d by 2 into sine c minus d by 2. Therefore, using first principle, f dash x is equal to limit h tends to 0, f of x plus h minus fx divided by h. Now, in place of f of x plus h minus fx, I put this value, limit h tends to 0 minus 2 cosine x plus h by 2 sine h by 2 by sine of x plus h into sine x Now you see h is the variable, therefore the sin x is constant in this case. It will be taken outside 1 by sin x. Minus 2 is also there, we can take that. This into limit h tends to 0 cos of x plus h by 2 by sin of x plus h. Actually, putting h equal to 0, finally the expression or the fraction is not undefined, therefore I take this part together, and there is sin h into limit h tends to 0 sin h by 2 into, to get the standard limit form, I divide the denominator h by 2 into, for adjustment it will be half, therefore minus 1 by sin x into, putting finally h equal to 0, what we get, it is cos x by sin x, and this becomes 1, that means minus cosec x 1 by sin x, that is cosec x, and cos x by sin x, that is cot x. Therefore ddx final state of cosec x will be equal to minus cosec x into cot x. Derivative of cosec x, we have got the result minus cosec x cot x. Already we have followed mechanical way and calculated the limit. Already it is mentioned that derivative is nothing but obtaining the value of limits. Thus derivative of cosec x is minus cosec x cot x. Now students, you do yourself the derivative of sec x following similar way. As it is sec x, therefore we have to write here 1 by cos x, cos of x plus h, and 1 by cos x, and finally you will get, I am writing down the result directly here, and you do yourself ddx of sec x is equal to sec x tan x. Next, I work out number 6, that is derivative of cot x. Though that will be similar to finding the derivative of tan x, I am working out that. I rub these. Therefore, f of x plus h minus fx will be cot, that means cos of x plus h by sin of x plus h minus cos x by sin x. Now we simplify. Sin of x plus h into sin x, sin x cos of x plus h minus cos x sin of x plus h. Now this is of the form sin a cos b minus cos a sin b. Therefore, numerator will be sin x minus h sin x plus h into sin x. Here x cancelled. Therefore, minus sin h by sin of x plus h into sin x. We have got the simplified value of f of x plus h minus fx, that is equal to minus sin h divided by sin of x plus h into sin x. Now I put this value here, and remember one thing, while you will be asked to find the derivative of a given function, using definition you must write such type of terms using first principle or by definition, like this. Limit h tends to 0 minus sin h sin of x plus h into sin x. Now you see sin h by h there, therefore we are getting the standard limit. Therefore ddx of cot x is equal to minus sign is taken outside into limit h tends to 0 sin h by h into limit h tends to 0 1 by sin of x plus h sin x. I have applied the theorem or law of limit x tends to 0 fx into gx or fx by gx, that will be equal to limit x tends to 0 fx numerator and denominator limit x tends to 0 gx. And finally got this form. Now this is standard limit, therefore minus 1 into, we have to put finally h equal to 0. What we get? Sin square x, sin x into sin x, sin square x. That means minus cosec square x. Therefore finally ddx of cot x equal to minus cosec square x. After finding out the derivatives of the functions already I have discussed, my suggestion is that you write down these derivatives in a table form or in chart like this. Thus, we have got ddx x to the power n is equal to n x to the power n minus 1 ddx of log x to the base e 1 by x ddx of e to the power x is equal to e to the power x. These are algebraic function. Now I add here d dx of e to the power x, that will be equal to e to the power x log of a to the base e. Now you can find out easily the derivative of a to the power x using the definition. Here I have written directly the result d dx of a to the power x equal to the power x into log of a to the base e. Actually, to find the derivative of a to the power x, we can use the derivative of e to the power x like this. You can find easily using definition. Also, we can find that like this in the indirect manner, d dx of a to the power x is equal to d dx of e to the power x log a into a to the power x is equal to e to the power x log a. And if we use the definition, then log a, to remove that log a, we have to actually, let me use that definition so that you can understand easily why log a will be there. Limit h tends to 0, e to the power x plus h log a minus e to the power x log a whole by h. I have used here the definition f of x plus h minus fx. Then you see e to the power x log a is common factor. E to the power x log a, e to the power h log a minus 1 by h. Now e to the power x log a is a constant as h tends to 0 here. Therefore, this will be e to the power x log a is taken outside into limit h tends to 0, e to the power h log a minus 1 h log a into log a. To use the standard limit, h log a is there as a index of e, therefore we have to take it here h log a at the denominator, and for balancing we have to multiply the whole by log a. That means e to the power x log a into limit, say k tends to 0, e to the power k minus 1 by k, and this log a will be placed here as it is constant. Here we are changing the variable k equal to h log a, therefore k tends to 0 as h tends to 0. Finally what we get, e to the power x log a, that is a to the power x into log a into, this is standard limit, therefore 1, therefore finally what we get, d dx of a to the power x is equal to a to the power x into log a. This is the deduction of the formula d dx of a to the power x equal to this. It is requested that you do yourself this part, though I have worked out here. Next, we write the next derivatives like this in the chart. Number 4, d dx of sin x is equal to cos x d dx of cos x minus sin x d dx of tan x is equal to sec square x d dx of cosec x is equal to minus cosec x cot x d dx of sec x tan x this will be 8 and this will be 9 d dx of cot x is equal to minus cosec square x. Make this chart, and initially you look at this chart and you try to memorize. It is a must for remembering these results. Now I have written for the purpose that you note the derivatives of the trigonometric functions which start with the letter C, and what we find that in the result there is minus sign. Therefore, in case of trigonometric functions, the derivative of the function starting with the letter C, there will be negative sign. d dx of cos x equal to minus sin x, d dx of cosec x is equal to minus cosec x cot x, d dx of cot x equal to minus cosec square x.